Hello everyone, welcome back to mahafarkar.co.in. In today's article, we are going to deal with vertical circular motion. In a previous videos, you must have learned that there are two types of circular motion. Uniform circular motion, which is in which the velocity of object who is performing the circular motion is always remains constant. Whereas the non-uniform circular motion, in which velocity of object performing circular motion changes at every point along the circumference of circle. So this vertical circular motion is also non-uniform circular motion. So first thing that we need to keep in mind that it is non-uniform circular motion. It is what? Non-uniform circular motion. That means its velocity is going to change at all the points. Okay. Now consider object is performing vertical circular motion. Means what here? If suppose this is the surface, earth surface, then the motion of object is perpendicular to the earth surface, or the plane of circle is perpendicular to the earth surface, then we called it is vertical circular motion. So consider one such article performing vertical circular motion. Say it is moving in an anti-clockwise sense. It is moving in an anti-clockwise sense. Because of its anti-clockwise motion, velocity at all the points will be directed like what I have shown at points A, then point B and point C. This is a point B and point C. So point A is at the topmost position, point B is at the lowest, very close to the ground, and point C is midway between A and B. Exactly similar, you have enjoyed giant wheel, ride of giant wheel in the fun fair. In that case, if you are sitting on the chair and that chair is continuously moving in that giant wheel, when you are at the top, when you are at the bottom, and when you are at the midway, your directions of velocity will be different, and that we are going to study here. So few things before learning vertical circular motion we need to keep in mind. First thing, that when object is performing vertical circular motion, energy, different forms of energy are changing, but the overall energy always remains constant. Different forms of energy are changing, but overall energy remains constant. Means what? When you are coming from point A to point B, your kinetic energy increases. Your kinetic energy what? Increases, but at the same time, potential energy decreases. This upward and downward arrows you consider as increases and decreases. So kinetic energy increases and potential energy decreases. But whereas if you are going from B to A, while going from B to A, your potential energy increases and kinetic energy decreases. Okay. But overall, at every point, sum of kinetic energy and potential energy always remains constant. So law of conservation of energy here also is obeyed. So just suppose that you have a stone tied to a string and whirled in a vertical circle. So say let m be the mass of object attached to that string. When it is rotating in a vertical circle, let r be the radius of the circle. Now as I said, say few points, say point A, if the position of object is the highest position. Point B is the position which is very close to the ground, say it is lowest position. And point C is between that A and B, so it will say it is at what? Say midway position. So we consider highest, lowest and midway positions. Now as I said, velocities, kinetic energies and all the factors are changing here. Because of that, say V1 is the velocity of that object, at point A, Say V2 is velocity of object at point B, and V3 be the velocity of object at point C. So these three are corresponding velocities at point A, B and C and their corresponding direction. If it is thrown, it is left here, then it will go tangentially, here it will go tangentially towards me, and here it will go up and then will fall down. Now when we consider that string is providing centripetal force, then tension is acting on that string. So let T1 be the tension acting on string, but which is at point A, and say T2 be the tension acting on the string, tension at point B. We will discuss about T3 in a later case. Now, when we discuss such conditions, all these parameters you have to keep in mind. So now discuss all the positions separately. So first let's discuss at highest position. So see what is going to happen at highest position. When vertical circular motion is performed, tension in the string, whatever is the position is there, it will always toward the center. Tension will be toward the center. But if suppose object is performing vertical circle and it is at the top, when it is at top, its weight will be downwards, and the tension which is acting there, that is also in the downward direction. In that case, I can say centripetal force which was required for the circular motion will be contributed by these both the factors, or that centripetal force should be equal to this one, because they both are directed toward the center, and the force which is directed toward center is nothing but what? Centripetal force. So at highest position, what is going to happen? Centripetal force required for circular motion, centripetal force required for circular motion is provided by tension T1 and weight mg, tension T1 and weight mg, and as both are along same direction, as therefore we can write if centripetal force here at point A is mv1 square upon r, centripetal force according to the formula is mv1 square upon r, then this centripetal force should be provided by this both, that means tension T1 plus mg. See how easy is this equation to understand? Or I can write T1 can be equal to mv1 square upon r minus mg. So combinedly I can call this as equation A. Okay. This is the condition for highest position. Now say at lowest position. At lowest position. At lowest position, that means at point B. Okay. Now what is happening at point B? Whenever you are there, wherever you are there, your position, whatever is the position, every time the weight is always directed towards the center of earth. So weight mg is directed downwards, but the tension acting on the string is in upward direction. So here also centripetal force for circular motion is provided by tension T2 and weight mg. So here I can write, here centripetal force will be provided by tension T2 and weight mg. So as you can see, the centripetal force, tension T2 and weight mg, or I can write this addition of this both should be equal to weight, means m v2 square upon r can be equal to T2 minus mg. Okay. Or I can say T2 equal to mv2 square upon r plus mg. This will be two equations, and this will be very important equation when we are dealing with the vertical circular motion. See, at point A, tension T1 and weight mg both are directed toward the center. In that case, centripetal force equal to sum of these both. That's what I have written here. But in this case, sum of these both equal to centripetal. So one going up, another going down. Sum of these both, that is T2 minus T1. Now why minus sign? Because they are oppositely directed. Both are vector quantities. So T2 minus mg is equals to mv2 square upon r, or we can get T2 equal to mv2 square upon r plus mg. These are two very important equations when we deal with vertical circular motion. Now we want to find out velocities of object at point A, that is value of v1, at point B, that is value of v2, and that point at point C, that is value of what? v3. So let's find it. Okay. So I have erased the board and I have written important formulae, that what we learn now. T1 equal to mv1 square upon r minus mg, which is for highest position. T2 equal to mv2 square upon r plus mg for lowest position. Now we are interested to find velocity at highest position, that is value of v1. Now when we want to find value of v1, just imagine that you have a stone tied to the thread and you are rotating it in a vertical circle. You are keep on rotating. Imagine now, तुमचा जो stone आहे, that stone is at highest position. Highest position ला आला आणि इथं आल्यानंतर त्याला टेन्शन खूप जास्त असेल, then what will happen? See, you have started rotating, it reaches to highest position, and here tension is very high, so it will fall down. Can it complete circle? Definitely not. To complete the circle, tension which is acting at point A, which is trying to pull it toward the center, should be very small. So let me write that at highest position, tension on string should be small, so that to avoid the flattening of the string. That is, so for mathematics we write small value means very close to 0. So T1 say approximately equal to 0. So if I write this, then what will happen with equation A? Therefore, equation A can be written as 0 is equals to mv1 square upon r minus mg. माइनस इधर आएगा, प्लस हो जाएगा, but we'll get mv1 square upon r equal to mg. M cancelled on both sides, so we will get v1 square equal to r into g. v1 equal to root of r into g. If your velocity is less than this, then that object will not complete circular motion, it will fall down. So velocity while performing vertical circular motion at highest position should be definitely greater than root of rg. If it is less than that, then object could not complete the circular track, and from point A it will flanken, it will move down. Okay, so now let's find velocity at lowest position. Velocity at lowest point, that value we have written is what? v2. Now to find this, we are going to use the law of conservation of energy. Initially I told you that when we are going from A to B, kinetic energy is increasing but potential energy is decreasing. Let's find them individually. From point A to B, decrease in a kinetic energy equal to, we'll write half mv2 square minus half mv1 square, where v2 is velocity at lowest position and v1 is the velocity at highest position. Mass is remain same. So you can see half of m is common, v2 square minus v1 square. Say this is equation 1 for this term. Now when we are saying that object is coming from A to B, decrease here, my mistake, increase in a kinetic energy. At the same time, potential energy decrease, so decrease in a potential energy is equals to, see now when it is at highest point, what is the potential energy according to formula for potential energy? If you remember, potential energy equal to what? mgh, we just want to find value of h. H means what? From ground, this height of point A. So it is R plus R becomes 2R. So potential energy at point A is 2 mgr, and when it will come to ground it will 0. So it will be say what? 2 mgr. So this is equation number 2. We have done by law of conservation of energy. By law of conservation of energy, we know delta kinetic energy is always equals to delta potential energy. So let's substitute the value. What we are going to get? Half m into v2 square minus v1 square equal to 2 mgr. See, m cancel both sides, 2 multiplied here. So v2 square minus v1 square equal to 4 into rg or 4 into gr. Okay. Therefore, we have value of v1 square. See, v1 square is what? Rg. v2 square minus rg equal to 4rg. Therefore, v2 square equal to minus rg इधर आएगा plus, so it will be 5rg. Therefore, v2 equal to root of 5rg. This is the value of velocity, linear velocity of particle performing vertical circular motion at the lowest position. Okay. Now, if velocity at lowest position is less than this, then particle will not able to go upside. It will come back again downside. So velocity should be greater than this, so it can go to point C and then to the A and then can complete vertical circle. Okay. Now these are 2 points that what we did now. Now final term we left velocity at midway position. Third, we are going to find out velocity at midway position. Okay. Now, at midway position also, whatever the total energy is there at point B, same will be there at point C. So what I will write directly here, according to conservation of energy, total energy at point C is equals to total energy at point, say A or B, whatever, you can write any point. But what is total energy? Total energy is always sum of kinetic energy plus potential energy, say at point C, equal to kinetic energy plus potential energy at point B. So what is kinetic energy at point C? At point C velocity is v3, so it will be like half m v3 square plus potential energy. Potential energy means what? This much of height is there. This much of height means nothing but radius. So mgh, that is what? R. So potential energy is what? mgr equal to kinetic energy at lowest position. We know that it is what? Half of mv2 square. But at the lowest position, height is 0. So potential energy is also 0. Dividing both sides by m will get cancelled. So half v3 square plus rg or gr equal to half v2 square. But what is value of v2 square? 5rg. 5rg. Okay. Now what I am doing is, I'll just shift this plus rg this side. So half, or directly half of cancel on both sides. No, sorry. Half v3 square is equals to half, or here I can write it is 5 by 2 rg minus rg. So it will be like 3 by 2 rg. Half of v3 square is equals to 3 by 2 rg. Half 2 to get cancelled, so I will get v3 square equal to 3 rg. Therefore, v3 is equals to root of 3 rg. This is the velocity of particle performing vertical circular motion at midway position. If now you want to find out velocity of particle at any point or centripetal force at any point, you have to consider the components. So that components you are going to consider, they are going to split by certain angles. So mg cos theta, mg sin theta, and you know those properly. So just consider these components mg sin theta, then mg cos theta. So corresponding values of centripetal forces will only change, the rest all is going to remain same. Now few things that you need to keep in mind. You are going to find energy at any point. Say if I take highest position, how to find energy at highest position? Total energy equal to kinetic energy plus potential energy. What is value of kinetic energy? Half of mv1 square plus potential energy is mg into 2r. Half of v1 is nothing but rg plus 2mrg. So it is like half rg plus 2rg, 2mrg, that will be 5 by 2 mrg. This will be the total energy that you are going to get at all the points. Similarly, so if you have find this is for point A, then you can find for point B also and point C also. You try it. And finally, you can find difference in the tensions. Difference in a tensions. To find this difference in a tensions at highest point, means you want to find out tension at lowest minus tension at highest. So what you need to do is you need to subtract equation A from B. That means you need to find out value of T2 minus T1, and when you will simplify this, you will get its value is 6 mg. That delta T will be 6 mg. If you want to find out it for midway and lowest position, then that you will get what? 3 mg. That you are going to get what? 3 mg. So I hope you understood this article also. These things you have to keep in mind as they are going to ask in a MHTCET exams that you will require for solving numerical. This is the simple article. 3 important formula that you have to remind. First one, velocity at highest position, velocity at lowest position, and velocity at midway position. Energy of particle in vertical circular motion is 5 by 2 mrg, and tension difference at lowest and highest position is 6 mg, and lowest and midway position is what? 3 mg, because at the midway position, highest position, tension is 0. Here 0, here 6 mg. So mean tension here is what? 3 mg. I hope you understood this article. Thanks for watching mahasarkar.co.in. Have a nice day.